We continue with the second subtopic of Chapter 1, mole concept. The learning outcomes. At the end of this topic, students should be able to A. Define the terms empirical and molecular formula. B. To determine empirical and molecular formula from mass composition or combustion data. And C. Determine a molecular formula from experiment. Before we start, I want to recall your previous knowledge about the calculation of number of mole. When mass in unit gram is given, number of mole is equal to mass in gram divided by molar mass. There are three types of chemical formula, which are empirical formula, molecular formula, and structural formula. We will discuss more detail about empirical formula and molecular formula. Chemical formula is a kind of shorthand used to describe the ratio of atoms of elements in a compound. Empirical formula is a formula that shows the simplest whole number ratio of the atoms of different elements present in a molecule, while molecular formula is a formula that shows the exact or actual number of atoms of different elements present in a molecule. Empirical formula can be determined quantitatively either from mass composition or combustion data. Let's try to answer this question. Given to you mass composition. The composition of an organic compound is 38.71% carbon, 9.68% hydrogen, and 51.61% oxygen. Its relative molecular mass is 62. What are the empirical and molecular formula of the compound? The first step is assume mass of sample equal to 100 gram. The second step is tabulate a table that contains elements, mass in gram, number of moles, and simplest mole ratio. There are three elements in the compound given, which are carbon, hydrogen, and oxygen. Since we already assume mass of sample is 100 gram, therefore mass of carbon is 38.71 gram, mass of hydrogen is 9.68 gram, and mass of oxygen is 51.61 gram. Next, calculate the number of mole by using the formula mass in gram divided by molar mass. Therefore, the number of mole of carbon is 3.2258 mole, number of mole of hydrogen is 9.68 mole, and the number of mole of oxygen is 3.2256 mole. Finally, find the simplest mole ratio by each number of mole divided by the smallest number of mole. The smallest number of mole is 3.2256 mole, which is the number of mole of oxygen. The simplest mole ratio of carbon is equal to 1, hydrogen is equal to 3, and oxygen is equal to 1. Thus, The empirical formula of the compound is CH3O. To determine the molecular formula, we will use the formula empirical formula multiplied with N equal to molecular formula. N multiplied with the empirical formula CH3O equal to 62. 62 is the relative molecular mass given from the question. Next, substitute all of the relative atomic mass values in the empirical formula. Finally, N is equal to 2. Insert N equal to 2 in the formula of molecular formula. Thus, the molecular formula of the compound is C2H6O2. The second example shows the correct step to determine empirical formula by using combustion data. Combustion of 2.30 gram of an organic sample X yields 3.30 gram of CO2 and 1.80 gram of H2O. Sample X contains carbon, hydrogen, and oxygen. Determine the empirical formula of X. There are 3 steps involved. Step 1. Find the mass of carbon and hydrogen of the organic compound from the combustion data. Mass of carbon will be calculated from the mass of carbon dioxide CO2 and mass of hydrogen will be calculated from the mass of water H2O. Step 2. Find the composition by mass of carbon, hydrogen and oxygen. Now we get already mass of carbon and hydrogen. Therefore, mass of oxygen is equal to total mass of sample minus mass of carbon and mass of hydrogen. Step 3. Calculate the empirical formula by using table like the first example. Please remember, never round off values close to whole number in order to get a simplest mole ratio, but multiply the value by a factor until you get a whole number. For the next part, we will continue with subtopic 1.2 mole concept to define all concentration measurement and to calculate all of the concentration measurement. That's all from me. Thank you.